Hello, everyone, and welcome back to another exciting episode of Think Tech. I'm your host Shivam, and today we are delving deep into the world of AI, specifically focusing on Retrieval Augmented Generation or RAGs. This isn't just a new trend in AI, it's a revolutionary approach that's reshaping how AI systems interact with and process information. So let's dive in. Retrieval augmented generation represents a significant evolution in the field of natural language processing. At its core, RAGs are a hybrid model combining the generative capabilities of neural language models like GPT or BERT with the dynamic information retrieval capacity of external databases. This combination allows AI systems to not only generate human like text, but also to pull in up to date, relevant information from external sources in real time. The concept of retrieval augmented generation is a product of collective innovation and research, but a few key players stand out in its development. One of the seminal papers on RAGs, titled Retrieval Augmented Generation for Knowledge Intensive NLP Tasks, was published by a team of researchers at Facebook AI Research or FAIR. The lead authors, Patrick Lewis and Ethan Perez, along with their colleagues, were driven by a desire to address the limitations of existing language models. They recognized that while models like GPT-3 were highly effective at generating human-like text, their inability to access and integrate external, up-to-date information was a significant limitation. This realization sparked the development of RAGs as a solution to bridge this gap. The work of these researchers at FAIR was influenced by and built upon previous advancements in natural language processing and information retrieval. The integration of these two fields wasn't entirely new, but the way the FAIR team approached it was definitely innovative. They leveraged the power of transformer-based models, which were already revolutionizing the field of NLP, and combined them in sophisticated retrieval systems. But let's break this down further. Traditional language models, while impressive in their ability to generate coherent and contextually relevant text, are limited by the data they were trained on. Their knowledge is static, frozen at the point of their last training update. RAGs address this limitation by integrating a retrieval system, which can be thought of as a dynamic, constantly updating database or a vast repository of information like the internet. The technical intricacies of RAGs are where things get really interesting. When a query is input into a RAG system, the first component that kicks into action is the retrieval system. This is where the process of understanding and finding relevant information begins. The retrieval system's job is to stifle through a vast database of documents to find out those that are the most relevant to the query. But how does it understand what's relevant? And this is where the magic of embedding techniques come in. Embedding techniques are used to convert the query, which is in text form, into a vector. A vector in this context is essentially a numerical representation of the query in a higher dimensional space. This conversion is crucial because it allows the system to perform mathematical operations to measure the similarity between the query and the documents in its database. Now let's talk about these mathematical operations. Two popular algorithms used in this context are BM25 and cosine similarity measures. BM25 is a sophisticated ranking function used by search engines. It's based on a probabilistic information retrieval model and considers factors like term frequency, that is how often a word appears in a document, and document length. Cosine similarity, on the other hand, measures the cosine of the angle between two vectors. In context of RAGs, it's used to determine how similar the query vector is to the document vectors in the database. The smaller the angle, the higher the cosine similarity, indicating a higher degree of relevance between the query and the document. The beauty of these algorithms lies in their ability to handle the complexity and nuances of language. They can discern relevance in a way that goes beyond simple keyword matching. For instance, they can capture semantic similarities, meaning they can recognize that words or phrases have similar meanings, even if they are not exactly the same. Once the relevant information is retrieved, it's passed to the language model, And here's where the generative magic happens. The language model synthesizes the retrieved information with its pre-existing knowledge base, generating a response that's not only relevant but also contextually rich and nuanced. The applications of RAGs are as diverse as they are exciting. In customer service, RAGs can provide more accurate and informed responses to customer queries by pulling in the latest product information or user manuals. In the academic world, they can assist researchers by quickly retrieving relevant studies, papers, or data. In the medical field, RAGs can aid in diagnostics and treatment planning by accessing the latest medical research and clinical guidelines. But the implementation of RAGs is not without its challenges. The effectiveness of a RAG system hinges on the quality of the data in the retrieval database. This is a critical point because if the retrieved information is inaccurate or outdated, the entire response generated by the AI system can be compromised. Therefore, maintaining a comprehensive and constantly updated database is essential, but this is easier said than done. Firstly, the sheer volume of information available is staggering. The internet is an ever expanding universe of data with new information being constantly added. Keeping a database not just comprehensive but also current is a monumental task. This requires not only automated systems to crawl and index new data, but also sophisticated algorithms to evaluate the relevance and the reliability of this information. Another challenge is the dynamic nature of the information. Facts can change, new research can emerge, and what was true yesterday might not be true today. This means that the retrieval system needs to be more than just a static repository of information. It needs to be dynamic, capable of adapting to the ever-changing landscape of data. Moreover, the question of bias and misinformation is a significant concern. The retrieval system might inadvertently pick up and propagate biased or false information if it's present in the source data. This necessitates the implementation of advanced algorithms that can detect and filter out unreliable or biased information. Ensuring the relevance and accuracy of the retrieved documents also involves sophisticated natural language understanding. The system must be able to discern the context and the nuance of the query to retrieve the most relevant documents. And this is where advanced AI techniques like deep learning and semantic analysis come into picture. These techniques allow the system to understand queries at a deeper level, just beyond the keywords matching. Furthermore, the system must be able to handle ambiguity and vagueness in queries. Humans often ask questions in a way that are not precise, and interpreting these queries accurately is a challenge for any AI system. The RAG system must be able to parse these queries, identify the underlying intent, and retrieve information that accurately addresses that intent. Another domain of challenges is the seamless integration of retrieval and generation components. This integration is crucial for maintaining the fluency and coherence of the generated text. The system must balance the retrieved information with the inherent knowledge of the language model, ensuring that the final output is not just a patchwork of information, but a cohesive and understandable response. Moreover, optimizing these systems for speed is essential for real-time interactions, a non-trivial task given the computational demands of both retrieval and generation processes. Beyond the technical challenges, there are also ethical considerations. The ethical implications of RAGs are multifaceted. One of the primary concerns is the potential for bias in the system. Bias in AI systems is often a reflection of the data they are trained on or the data they have access to. Since RAGs rely on external data for retrieval, the choice of data is crucial. And as discussed, if the source data is biased, the AI responses will likely be biased too. Bias can manifest itself in many forms. It could be gender bias, racial bias, or even socioeconomic bias. For instance, if a RAG system is predominantly retrieving information from sources that have a certain geographical or cultural perspective, its responses may inadvertently reflect the viewpoints or limitations of those perspectives. Another ethical concern is the authenticity of information. When RAGs blend retrieve content with generated content, it can sometimes be challenging to distinguish between what the AI generated and what is sourced from external data. This raises questions about the authenticity of the information provided. In an era where misinformation can have serious consequences, the potential for RAGs to inadvertently spread false or misleading information is a concern that needs to be addressed. Moreover, the use of external data sources brings up the issue of copyright. RAGs might retrieve and repurpose content that is copyrighted, which raises legal and ethical questions about the use of such content without proper attribution or permission. Addressing these ethical considerations requires a multifaceted approach. It's not just about refining algorithm, it's also about the governance and the oversight of these systems. This includes establishing ethical guidelines for data selection, continuous monitoring for bias, and maybe implement a robust fact-checking mechanisms to ensure authentic data generation. Retrieval augmented generation is a groundbreaking advancement in AI, pushing the boundaries of how machines understand and interact with human language. It's a complex blend of retrieval, machine learning, and natural language processing, and is evolving rapidly. As we continue to refine and develop these systems, the potential applications are vast and deeply impactful. And that wraps up our episode today. A brief introduction to the key concepts related to retrieval augmented generation. I hope you have learned something new and exciting. If you have enjoyed this episode, please subscribe and share it with your friends. I'll be back soon with more tech topics simplified just for you. Until next time, I am Shivam signing off.